Peanut allergies have become a growing concern in recent decades. Once a relatively rare occurrence, they are now increasingly common, particularly in developed countries. This dramatic rise has left many people wondering why so many individuals, especially children, are developing allergies to this common legume. The increase in peanut allergies is not just an interesting phenomenon, it's a serious public health issue with potentially life-threatening consequences. Imagine a child enjoying a seemingly harmless snack, only to experience a sudden onset of hives, itching, and difficulty breathing. This is the reality for millions of people living with peanut allergies. For them, even trace amounts of peanuts can trigger a severe, potentially life-threatening allergic reaction known as anaphylaxis. This alarming scenario underscores the importance of understanding why peanut allergies are on the rise and what can be done to prevent and treat them. The rise of peanut allergies is not just anecdotal, it's backed by alarming statistics. Over the past few decades, the number of people affected by peanut allergies has surged dramatically, causing concern among healthcare professionals and researchers alike. Studies show that the prevalence of peanut allergies has more than tripled in recent decades, particularly in westernized countries. This sharp increase is not just a minor uptick, it represents a significant public health challenge that requires immediate attention and action. In the United States, for example, it's estimated that over 3 million people have a peanut allergy, including approximately 1 in 13 children. This means that in a typical classroom, at least 2 children are likely to be affected, making it a common concern for parents, teachers, and school administrators. These figures paint a stark picture of a silent epidemic affecting millions worldwide. The rise in peanut allergies is not confined to any one region. It is a global issue that transcends borders and cultures, impacting people from all walks of life. The statistics are even more concerning when we consider the severity of peanut allergies. For many, the reaction to peanuts is not just a minor inconvenience, but a serious, life-threatening condition that requires constant vigilance and preparedness. While some individuals may experience mild reactions, others can go into anaphylaxis, a life-threatening allergic reaction that can cause the throat to close, the airways to constrict, and the blood pressure to drop dangerously low. This severe reaction can occur within minutes of exposure and requires immediate medical intervention to prevent fatal outcomes. Every year, thousands of people require emergency medical treatment for anaphylaxis caused by peanut allergies, highlighting the urgent need for effective prevention and management strategies. The healthcare system is continually challenged to provide timely and effective care for these emergencies, emphasizing the importance of awareness, education, and research in combating this growing health issue. While peanut allergies are most prevalent in westernized countries, they are by no means confined to these regions. Studies show that peanut allergies are on the rise globally, albeit at varying rates. This suggests that while certain environmental factors common to westernized lifestyles may play a role, other universal factors are also likely contributing to the global increase in peanut allergies. Interestingly, the prevalence of peanut allergies varies significantly across different geographic regions. For instance, peanut allergies are less common in some Asian countries where peanuts are a staple food and are introduced early in life. In contrast, peanut allergies are more prevalent in countries where peanuts are often consumed as snacks and introduced later in childhood. These observations have led researchers to investigate the role of dietary practices and early life exposures in the development of peanut allergies. Peanut allergies are more than just a personal health concern. They represent a significant public health issue. The increasing prevalence of peanut allergies places a burden on healthcare systems, educational institutions, and the food industry. Addressing this issue requires a multifaceted approach involving education, prevention, and improved management strategies. In schools and childcare settings, managing peanut allergies often involves implementing strict peanut-free policies. While these measures are crucial for protecting allergic individuals, they can also be challenging to enforce and can sometimes lead to social isolation for those with peanut allergies. Educating children, parents, and staff about peanut allergies and promoting empathy and understanding are essential for creating safe and inclusive environments. Section 5. Unlocking the Mystery, a Quest for Answers. The dramatic rise in peanut allergies has spurred a wave of research aimed at unraveling the mysteries surrounding this complex condition. This surge in cases has not only alarmed parents and healthcare providers, but has also caught the attention of the scientific community worldwide. Scientists around the world are working tirelessly to understand the underlying causes of peanut allergies, identify potential risk factors, and uncover the genetic and environmental triggers that contribute to this condition. Their dedication is unwavering as they delve deeper into the complexities of the human immune system and develop effective prevention and treatment strategies. These strategies range from early dietary interventions to potential immunotherapies that could one day offer a cure or at least significant relief for those affected. This quest for answers is driven by the urgent need to alleviate the burden of peanut allergies on individuals, families, and healthcare systems. The emotional and financial toll on families is immense, and the healthcare system is constantly seeking better ways to manage and treat this growing epidemic. Researchers are employing cutting-edge technologies and innovative approaches to investigate the intricate mechanisms involved in peanut allergies. These technologies include advanced genetic sequencing, bioinformatics, and sophisticated laboratory models that mimic the human immune response. From studying the role of genetics and the human microbiome, which involves the trillions of microorganisms living in our bodies, to exploring the impact of environmental exposures and dietary practices, researchers are leaving no stone unturned. They are examining how factors like pollution, diet, and even lifestyle choices can influence the development of peanut allergies. Scientists are gradually piecing together the puzzle of peanut allergies. By connecting various research findings, they are building a comprehensive understanding of how this condition develops and progresses. Each new discovery brings us closer to understanding why some individuals develop this life-altering condition while others do not. These breakthroughs offer hope for new treatments and preventive measures that could one day make peanut allergies a thing of the past. Section 1. Decoding the allergic reaction, what happens inside the body. In this section, we will explore the fascinating and complex processes that occur within the body during an allergic reaction, specifically focusing on peanut allergies. To truly understand peanut allergies, we need to delve into the intricate workings of the human immune system. The immune system is a highly sophisticated network of cells, tissues, and organs that work together to defend the body against harmful invaders. In a typical immune response, our bodies defend against harmful invaders like bacteria and viruses. White blood cells, such as macrophages and neutrophils, play a crucial role in identifying and neutralizing these threats. However, in the case of a peanut allergy, the immune system mistakenly identifies certain proteins in peanuts as dangerous threats. This misidentification is due to a hypersensitivity reaction, where the immune system overreacts to a harmless substance. This triggers a cascade of reactions that lead to the symptoms we associate with an allergic reaction. The body releases various chemicals, including histamine, which cause inflammation and other allergic symptoms. When a person with a peanut allergy consumes even a tiny amount of peanut protein, their immune system springs into action. The body perceives the peanut proteins as a significant threat and initiates an immediate response. Specialized cells called B cells release antibodies, specifically immunoglobulin E (IgE) antibodies, which are programmed to target peanut proteins. These antibodies are produced in large quantities and circulate throughout the body. These IgE antibodies then attach themselves to mast cells, which are found in tissues throughout the body, particularly in areas like the skin, airways, and digestive tract. When these mast cells encounter the peanut proteins again, they release a variety of chemicals, including histamine, leading to the symptoms of an allergic reaction, such as itching, swelling, and difficulty breathing. Understanding these processes is crucial for managing and treating peanut allergies. By knowing how the immune system reacts, we can develop better strategies to prevent and mitigate allergic reactions, ensuring the safety and well-being of those affected. Section 2. Common symptoms. Recognizing the signs of a peanut allergy. Peanut allergies can manifest in a wide range of symptoms, varying in severity from person to person. Some individuals may experience mild, localized reactions, while others may have severe systemic reactions affecting multiple organ systems. It's important to be aware of the common symptoms of peanut allergies so that prompt action can be taken if a reaction occurs. Skin reactions are among the most common symptoms of peanut allergies. These can include hives, which are red, itchy welts, eczema, which are dry, itchy patches of skin, and swelling of the lips, tongue, face, or throat. Digestive symptoms are also frequent and can range from mild nausea and abdominal cramps to severe vomiting and diarrhea. Anaphylaxis is the most severe form of allergic reaction and can be life-threatening if not treated immediately. It is a systemic allergic reaction that occurs rapidly, typically within minutes of exposure to the allergen, in this case, peanuts. During anaphylaxis, the body releases a flood of chemicals that cause a wide range of symptoms, some of which can be life-threatening. One of the hallmarks of anaphylaxis is a rapid drop in blood pressure, known as anaphylactic shock. This occurs because the chemicals released during the reaction cause the blood vessels to widen, leading to a sudden decrease in blood pressure. This can lead to dizziness, fainting, and, in severe cases, organ failure. Diagnosing peanut allergies involves a combination of medical history, physical examination, and specific allergy tests. A detailed medical history is crucial for the allergist to understand the individual's symptoms, the timing of reactions, and any potential triggers. This includes information about past exposures to peanuts, family history of allergies, and any other allergies the individual may have. A physical examination helps the allergist assess the individual's overall health and look for any signs of allergies, such as eczema or other skin conditions. The allergist may also listen to the individual's heart and lungs to check for any wheezing or other respiratory symptoms. Living with a peanut allergy requires constant vigilance and careful management. Avoiding peanuts in all forms is crucial for preventing allergic reactions. This means reading food labels carefully, asking questions when dining out, and being mindful of potential sources of cross-contamination. Individuals with peanut allergies and their families need to become experts at reading food labels. Peanut ingredients can be hidden in unexpected places, so it's essential to check labels every time, even for familiar products. Look for clear labeling that states contains peanuts or may contain peanuts. Be aware of common peanut ingredients, such as peanut butter, peanut oil, and peanut flour. Empowering individuals with peanut allergies and their families with knowledge and skills is paramount to effectively managing the condition. Education plays a crucial role in helping individuals understand their allergies, recognize potential triggers, and take appropriate steps to prevent and manage allergic reactions. It's essential for individuals with peanut allergies to carry 2 epinephrine auto-injectors, like EpiPen or Auvi-Q, at all times. Epinephrine is a life-saving medication that can rapidly reverse the symptoms of anaphylaxis. Individuals with peanut allergies and their caregivers should be trained on how to recognize the symptoms of anaphylaxis and administer epinephrine properly. Peanut allergies often run in families, suggesting a strong genetic component to their development. This means that if a close family member, such as a parent or sibling, has a peanut allergy, there is a higher chance that other family members might also develop the condition. This familial pattern is due to the inheritance of specific genes that predispose individuals to allergic reactions. These inherited traits can influence how the immune system responds to allergens. For example, certain genetic variants can lead to an overactive immune response when exposed to peanut proteins, triggering an allergic reaction. Researchers have identified several genes that are associated with an increased risk of developing peanut allergies. These genes are involved in the regulation of the immune system and its ability to distinguish between harmless substances and harmful invaders. Family history is a powerful indicator of an individual's risk for developing peanut allergies. Numerous studies have shown that children with parents or siblings who have peanut allergies are significantly more likely to develop the allergy themselves. This pattern highlights the importance of genetic factors in the development of peanut allergies. Parents who have a history of allergies, whether to peanuts or other substances, often pass on genes that make their children more susceptible to allergic reactions. These inherited genes can affect various aspects of the immune system, including its sensitivity to allergens and its propensity to overreact. This genetic predisposition, combined with environmental exposures, can set the stage for the development of peanut allergies. Section 3. Genetic markers. Identifying allergic predispositions. The identification of genetic markers associated with peanut allergies is a crucial step in understanding why certain individuals are more susceptible to developing this condition. Genetic markers are specific sequences of DNA that can indicate an increased risk for a particular disease or condition. In the case of peanut allergies, researchers have identified several genetic markers that are linked to an increased risk of allergic reactions. One of the key genetic markers associated with peanut allergies is found in the region of the genome that encodes for the immune system's response to allergens. Variations in genes such as HLA-DR and HLA-DQ have been linked to an increased likelihood of developing peanut allergies. These genes play a role in how the immune system recognizes and responds to foreign proteins, including allergens. Section 4. The human genome and peanut allergies, recent discoveries. Recent advancements in genomic research have provided new insights into the complex relationship between our genes and peanut allergies. The sequencing of the human genome has opened up new avenues for understanding how specific genetic variations contribute to the development of allergic diseases, including peanut allergies. This research is shedding light on the intricate interactions between various genes and environmental factors. One of the most significant discoveries in recent years is the identification of multiple genetic loci associated with an increased risk of peanut allergies. These loci are regions of the genome that contain multiple genes, each contributing to the overall risk. For example, the 11q13 and 5q31.1 loci have been linked to peanut allergies, with each region containing several genes involved in immune regulation and response. Section 5. Gene-environment interactions, the complex dance. The development of peanut allergies is not solely determined by genetics. Environmental factors also play a crucial role. The interplay between genes and the environment, known as gene-environment interactions, is a key area of research in understanding peanut allergies. These interactions help explain why some individuals with a genetic predisposition develop peanut allergies, while others do not. One of the most well-documented environmental factors influencing peanut allergies is early life exposure to allergens. Studies have shown that the timing and amount of peanut exposure in infancy can significantly affect the likelihood of developing an allergy. For example, the LEAP, or Learning Early About Peanut Allergy, study demonstrated that early introduction of peanuts to high-risk infants can reduce the incidence of peanut allergies. Section 6. Twin studies, insights into heritability. Twin studies have been instrumental in understanding the heritability of peanut allergies and the relative contributions of genetic and environmental factors. By comparing the prevalence of peanut allergies in identical or monozygotic twins who share 100% of their genes to fraternal or dizygotic twins who share about 50% of their genes, researchers can estimate the heritability of peanut allergies. Studies have shown that identical twins are more likely to both have peanut allergies compared to fraternal twins, suggesting a strong genetic component. However, not all identical twins both develop peanut allergies, indicating that environmental factors also play a critical role. This combination of genetic and environmental influences is a hallmark of complex diseases like peanut allergies. Section 7. Future directions in genetic research, hope on the horizon. The future of genetic research in peanut allergies holds great promise for improving our understanding of this condition and developing new strategies for prevention and treatment. Advances in genetic technologies such as next-generation sequencing and CRISPR gene editing are opening up new avenues for research and offering hope for individuals affected by peanut allergies. One exciting area of future research involves the use of precision medicine approaches to tailor prevention and treatment strategies based on an individual's genetic profile. By identifying specific genetic variants associated with peanut allergies, researchers can develop personalized interventions that target the underlying mechanisms of the condition. This could include targeted immunotherapies, dietary modifications, and other tailored treatments. Section 1. Beyond Genes. Exploring environmental triggers. While genetics play a significant role in peanut allergies, they don't paint the whole picture. Increasingly, researchers are focusing on environmental triggers as crucial players in the development of peanut allergies. These triggers, often interacting with genetic predispositions, can influence the delicate balance of the immune system, leading it to misidentify peanut proteins as threats. One of the key areas of focus is the timing and nature of first exposures to peanuts. Studies suggest that early introduction of peanuts, even in infancy, might actually be protective against developing allergies later in life. This concept challenges the traditional avoidance approach, highlighting the complex interplay between exposure, immune development, and allergy risk. Section 2. The Hygiene Hypothesis, Too Clean for Our Own Good. The hygiene hypothesis has emerged as a prominent theory attempting to explain the rising rates of allergies, including peanut allergies, in developed countries. This intriguing hypothesis suggests that our modern obsession with cleanliness might be backfiring, depriving our immune systems of crucial training opportunities in early life. According to this theory, exposure to microbes, such as bacteria and viruses, in early childhood is essential for teaching the immune system to differentiate between harmless and harmful substances. These exposures, often encountered through everyday activities like playing outside, interacting with pets, and being exposed to dirt, help educate the immune system, preventing it from overreacting to harmless substances like peanut proteins. Section 3. Dietary influences, the role of food introduction. The timing and manner in which infants are introduced to allergenic foods, including peanuts, have become a focal point in peanut allergy research. Traditional advice often encouraged delaying the introduction of allergenic foods to prevent allergies. However, recent research suggests that this approach might be counterproductive, potentially increasing the risk of developing allergies. The LEAP, Learning Early About Peanut Allergy study, a landmark clinical trial, challenged conventional wisdom by demonstrating that early and consistent introduction of peanuts to high-risk infants significantly reduced the likelihood of developing peanut allergies by age 5. This groundbreaking study provided strong evidence for early introduction as a potential preventive strategy for peanut allergies. Section 4. Skin exposure and the allergic march, a complex relationship. The skin, our body's largest organ, plays a crucial role in immune system development and the development of allergies, including peanut allergies. The allergic march refers to the progression of allergic diseases that often begins in infancy with eczema, a chronic inflammatory skin condition characterized by dry, itchy, and inflamed skin. Research suggests that infants with eczema, particularly moderate to severe eczema, have an increased risk of developing food allergies, including peanut allergies, later in life. This link between eczema and food allergies highlights the importance of maintaining healthy skin barrier function in early life. Section 5. The Microbiome Connection, Gut Bacteria and Immune Development. Emerging research points to a fascinating link between the trillions of bacteria residing in our gut, collectively known as the gut microbiome, and the development of peanut allergies. The gut microbiome plays a crucial role in shaping immune system development, influencing its ability to distinguish between harmless and harmful substances. Studies have shown that infants who develop peanut allergies often have differences in the composition of their gut microbiome compared to those who don't. These differences, characterized by an imbalance in the types and diversity of gut bacteria, can disrupt the delicate balance of the immune system, potentially leading to allergies. Section 6. Environmental pollutants, a growing concern. In addition to the factors discussed earlier, exposure to environmental pollutants is emerging as a potential contributor to the rising rates of peanut allergies. These pollutants, often present in the air we breathe, the water we drink, and the food we eat, can disrupt the delicate balance of the immune system, increasing the risk of allergic diseases. Air pollution, particularly from traffic-related emissions and industrial activities, has been linked to an increased risk of developing allergies, including peanut allergies. These pollutants contain harmful substances such as particulate matter, nitrogen dioxide, and ozone, which can trigger inflammation in the airways and disrupt immune system function. Section 1. Advancing the front lines, current research on peanut allergies. The fight against peanut allergies is a dynamic field with scientists around the world actively engaged in groundbreaking research. Driven by the urgency to alleviate the burden of this life-altering condition, researchers are exploring a wide range of avenues, from understanding the intricate mechanisms of allergic reactions to developing innovative treatments and preventive strategies. One prominent area of research focuses on immunotherapy, a promising approach that aims to gradually desensitize the immune system to peanut allergens. This typically involves controlled exposure to small, increasing amounts of peanut protein under strict medical supervision. The goal is to train the immune system to tolerate peanuts, reducing the severity of allergic reactions and potentially achieving long-term remission. Section 2. Immunotherapy. Desensitizing the immune system. Immunotherapy has emerged as a beacon of hope for individuals with peanut allergies, offering the potential for long-term relief from the fear and restrictions associated with this condition. This innovative approach aims to retrain the immune system, gradually desensitizing it to peanut allergens. One common form of immunotherapy is oral immunotherapy, or OIT, which involves ingesting small, controlled doses of peanut protein under strict medical supervision. The process typically starts with minuscule amounts, gradually increasing over time. This gradual exposure allows the immune system to build tolerance, reducing its sensitivity to peanut allergens. Section 3. Emerging therapies, new hope on the horizon. The quest for more effective and safer treatments for peanut allergies continues to drive innovation in the field of allergy research. Emerging therapies, still in various stages of development, hold the potential to revolutionize how we manage and treat peanut allergies in the future. One promising area of research involves the development of epicutaneous immunotherapy, or APIET. This innovative approach delivers peanut allergens through a patch applied to the skin. EPIT aims to desensitize the immune system through a less invasive route than OIT or SLIT, potentially reducing the risk of systemic allergic reactions. Section 4. The potential of biologics targeting specific pathways. Biologics, a new class of medications that target specific molecules involved in the immune response, are emerging as a promising avenue for treating peanut allergies. Unlike traditional allergy medications that address symptoms, biologics aim to interrupt the underlying mechanisms of allergic reactions. One such biologic, omalizumab, also known as Xolair, is already approved for the treatment of severe asthma and chronic idiopathic urticaria, or hives. Omalizumab works by blocking immunoglobulin E, or IgE, the antibody responsible for triggering allergic reactions. Studies are underway to investigate its potential in peanut allergy treatment. Section 5. Dietary interventions, beyond avoidance. While strict avoidance of peanuts remains the cornerstone of peanut allergy management, researchers are exploring dietary interventions that go beyond simple avoidance, aiming to modulate the immune response and potentially reduce allergy risk. One area of interest focuses on the gut microbiome, the trillions of bacteria that reside in our intestines. The gut microbiome plays a crucial role in immune system development and function, and imbalances in its composition have been linked to an increased risk of allergies. Section 6. The future of peanut allergy. Research. Collaboration is key. The future of peanut allergy research is bright, fueled by a global community of scientists, clinicians, and patient advocacy groups working together to advance our understanding and treatment of this challenging condition. Collaboration is essential for accelerating progress and translating research findings into tangible benefits for individuals with peanut allergies. International research collaborations are crucial for sharing data, resources, and expertise. By pooling knowledge and resources, researchers can conduct larger-scale studies, expedite the development of new therapies, and ensure that research findings are applicable to diverse populations worldwide. Section 1. A new era of hope, progress, and promise in peanut allergy research. The landscape of peanut allergy research has undergone a remarkable transformation in recent decades, offering a renewed sense of hope for individuals and families affected by this challenging condition. Once considered a life sentence of strict avoidance, peanut allergies are now increasingly viewed as a condition that can be managed, treated, and potentially even prevented. Advancements in our understanding of the immune system, genetics, and environmental triggers have paved the way for innovative therapies and preventive strategies. Immunotherapy, once a distant dream, is now a reality for many, offering the potential for long-term relief from the fear and restrictions associated with peanut allergies. Living with a peanut allergy can be challenging, requiring constant vigilance, careful planning, and emotional resilience. However, knowledge is power, and empowering individuals with the information and resources they need to manage their condition is crucial for improving their quality of life. Education plays a vital role in empowering individuals with peanut allergies. Understanding the basics of allergic reactions, recognizing potential triggers, and knowing how to administer life-saving epinephrine in case of anaphylaxis are essential for staying safe. Section 3. A global perspective. Addressing peanut allergies worldwide. While peanut allergies are most prevalent in westernized countries, they are a growing concern worldwide, affecting individuals and families across diverse cultures and socioeconomic backgrounds. Addressing this global health challenge requires a collaborative effort, recognizing that peanut allergies are not confined by geographical boundaries. Sharing research findings, best practices, and resources across borders is crucial for advancing our understanding and treatment of peanut allergies globally. International research collaborations can help identify regional variations in prevalence, risk factors, and treatment responses, leading to more tailored and effective interventions. Section 4. The power of prevention, early intervention, and lifestyle factors. While research continues to explore new treatments for peanut allergies, prevention remains a critical area of focus. Emerging evidence suggests that early intervention and certain lifestyle factors might play a significant role in reducing the risk of developing peanut allergies in the first place. The LEAP study and other research have revolutionized our understanding of early peanut introduction, demonstrating that early and consistent exposure to peanut-containing foods in infancy, particularly in high-risk infants, can significantly reduce the likelihood of developing peanut allergies later in life. Section 5. Looking ahead, unanswered questions and future directions. Despite significant progress in peanut allergy research, many unanswered questions remain, fueling the need for continued exploration and discovery. Unraveling the remaining mysteries surrounding peanut allergies will require innovative research approaches, collaborative efforts, and a commitment to pushing the boundaries of our current understanding. One area ripe for further investigation is the complex interplay between genes and the environment. While we know that both factors contribute to peanut allergy development, the precise mechanisms by which they interact remain elusive. Understanding these interactions is crucial for developing more targeted and effective prevention and treatment strategies. Section 6. A shared vision towards a world without peanut allergies. The ultimate goal of peanut allergy research is to create a world where peanut allergies are no longer a threat. This shared vision, while ambitious, is fueled by the collective efforts of researchers, clinicians, patient advocates, and families affected by this challenging condition. Achieving this vision requires a multifaceted approach that encompasses prevention, treatment, and support. Early intervention strategies such as early peanut introduction hold promise for reducing the incidence of peanut allergies in future generations.